Okay, we are celebrating the birthday of Egon Börger. His contributions and achievements to computer science have been so important that we should really congratulate him and say, my goodness, Egon, we hope that you continue your research. I will concentrate for this talk on models and modeling in computer science and give you at least some insight we have been developing for models in computer science. Egon's and his crowd achievements have been concentrating in the last 20-30 years on abstract state machines. Essentially, they are model suites for programming. We use two models. One is based on our ideas and concepts, which are ordered and then used for building a first model. With this first model, we construct a second model that can be seen as a model of our thoughts, of our intentions. And we use as a second model, M3, an environment model based on our paradigms that comes from our deep understanding, deep thoughts, from our matrix, disciplinary matrix especially. And then we generate maybe a program out of this specification. We have some kind of systematic refinement, especially for this generative approach. And this has been based on a good number of showcases how ASM is really successfully applied. I'm really happy that I was a member of the BPMN semantification showcase, where we could show that the ASM approach provides a far better semantics than what has been given in the standards, and survived further development of the standards. Why do we model so often? There are a number of reasons. One is an origin is typically pretty complex. Another one is we are limited in our ways how to reason. That means we have a little bit a problem with information overflow, and of course we should avoid some areas we should not consider. Typically data, biases, interpretations, hidden aspects, understanding problems, separation of concern and concentration are forcing us to model in a proper way. So it means in this case, modeling is essentially done everywhere. In life, science and engineering. By anybody, by everybody, for everybody, at any sphere, in any context. That means in this case, we might have a good number of different models, but we can separate these models by the aspects to the model. One is we are concentrating on the representation. Another one is we concentrate on the realization of the context. The third one is we concentrate on the foundation to make things understandable, maybe formalizing. And the fourth one that we often don't consider is the life or interaction aspects. Let's say for description and prescription scenarios, we are mainly somehow concentrating on the representation aspect and on the realization and context aspect. That means we are concentrating on some of these aspects in order to construct things. Okay, so that means in this case we might have a way how to handle models. And this will lead us directly to a very bad observation. Mathematics succeeded in the middle of the last century to become a little bit better digestible and again teachable. The Bourbaki group has been developing three main dimensions. Maybe we should ask ourselves whether in computer science we have something like that. My claim is we have essentially 4 dimensions, maybe plus 2 if we consider approximation and also interaction for computer science. That means in this case we have something like dimension first. The first dimension is state, the second is transformation, the third one is collaboration, and my claim is the fourth one is models. states, we have in the large and the small, we have also transformation in the large and the small, we have collaboration based on the 3C, communication, coordination, cooperation, or on collaboration in the large based on exchange architectures and services, and we have the same for models. Models, how they are built, and models, what are our guiding principles for modeling. Let's consider how it looks like in computer science. In databases and information systems, we heavily use models and mainly concentrate on states. A little bit on transformation, a little bit on collaboration, not more. In theoretical computer science, we are still not really wanting to consider models in a larger extent. We are not also concentrating on states. We are mainly using our thoughts, our developments on transformations. The same can be maybe done for software engineering, or a similar observation can be made for communication systems, where we are mainly concentrating on collaboration. That means especially on communication, a bit on coordination, and a bit on cooperation based on the protocols we are developing. Models are not really the issue. We can make it a little bit more systematically, let's say providing a table showing how it looks like. We have a number of disciplines. The theoretical computer science, for instance, loves to think about transformation. We consider bit states. Collaboration is not an issue. Modeling might become in the future an issue, but it's not really the main issue. Human-computer interfaces are not the issue at all, and approximation is not yet an issue, but it will become an issue. If you look for information systems and database systems, then in this case we concentrate on states and heavily use modeling. We use some kind of transformation facilities as well. That means in this case we have maybe a completely different approach compared to theoretical computer science. If you look, for instance, for applied computer science, then of course models are in the center of consideration. That means in this case we have very different ways how to handle these in different ways. But I claim modeling will become more and more important for most subdisciplines in computer science. Nowadays we meet a lot of, let's say, claims that modeling is not important at all. There are a number of myths that should be considered. For instance, modeling can be done by everybody and it's nothing else as a handicraft or an art by everybody, and for this reason we should not teach modeling as a special subdiscipline. We might also think that models can be directly discarded after being used. Quite often I hear that each hype must have its modeling language. And very often I hear there is no commonly acceptable notion of model. I claim that this is completely untrue, and for this reason we should have maybe a little bit more insight. We have maybe 1001 notion of models. We might have the claim that we would like to look for generic models that can be refined, or maybe for general notion of a model. Maybe we should start with the architecture. What is a model? What makes a model? Architecture is mainly built on some kind of background. We don't talk so much about it. That is the green part especially. The mold as a matrix part. Also the yellow part is somehow assumed to be given. We have supporting means, we have enabling means, and we have a context. Typically we don't talk so much about this. We have, of course, for a model something like an application sphere and an application scenario. And models are used as instruments. They reflect origins and they are used for obtaining a result. That means we have a model of and a model for. That means in this case models are somehow handled in a very specific way. 2. Now we might ask, is there any way to have some kind of general notion of a model again? What makes something to become a model? We have the general approach given by Stachorwerk. There is an origin or an original, there is an abstraction, there is a purpose. We claim that it is a little bit too specific and a little bit less general as we need. For this reason, we might use the rhetoric frame given by Hermann Goras of Temnos. Who, what, when, where, why, in what way, by what means. We are using models. This maybe is the way how to handle it. And in this case, we come directly to an anatomy of a model being. We should have origins. We have, of course, a usage, and in this case, the model becomes an instrument. We have goals, purposes, and function, why we use a model. We use it in a certain domain, in a certain context. We concentrate, we focus on something, and we have some kind of inherent, implicit, assumed things, and we have maybe something that is supported by our models. And of course, we have enablers, and of course, models are represented in a certain way, and typically we use a model suite, especially an informative model for the general display, maybe a diagram or something like that, and of course also a formal model. That means in this case we are using a model suite. That means the model being can be based on these 9 agenda points for the anatomy. Can we find now a notion of a model? A model is an instrument that functions in applications, and the main properties of a model should be adequacy and dependability. I will explain in a minute. A model is nothing else as it should be adequate. That means it should be analogous. It should be also focused and purposeful. That is accepted by everybody. We realize, however, that as a hidden part, we don't tell so much, but we have to. A model should be dependable. That means we should have a reason to believe in this model. That means we have a justification, and of course we are pleased by the quality of the model. That means in this case we have to get it this way. That means we have to consider the background, the matrix, and the model functions based on the origins we are using, based on the context, based on the community of practice we target. That means in this case a model is nothing else as an instrument that is adequate and dependable. For this reason I was putting here model, instrument, adequate and dependability in the corner of this slide. Now we can derive something like a signature, like we do in logics. In logics we say, okay, fine, how a specific language is defined in what way. We can do it the same based on this model notion. We begin with some stereotype we use in our subdiscipline. We have some disciplinary parts, we have some matrix parts, we have a situation, we have a theory behind, and we have some kind of maybe enabling facility. And in reality, we specify nothing else as the model content, data, tracks, events, whatever is in the model. And if you look here, you see a general onion approach that is, for instance, used in LaTeX for writing a document and for generating, finally, maybe a PDF. Okay, now we can look whether we have a model theory, what it means, model-based reasoning, how we can use a model in a very skilled way. What is the culture of models and modeling? Okay, let's start with some background insights. Anything can be a model, depending on whether we want to use it. Models could be specifications, but they don't have to be. One essential part is model-based reasoning, and model-based reasoning goes far beyond deductive calculi. We are concentrating mainly on the usage, the usefulness and the utility of the instrument. That means, in this case, we have maybe a very specific viewpoint. And we have invariance. We transport from the origins something to the model and deliver it for the result, or to the result. And we can specify the model based on this rhetoric frame or the generalized WH frame. Models should be never complete. We want to focus. And of course, typically we use a number of model suites. Reasoning now means in this case we should enhance the reasoning by induction and abduction. Oh no, we should even have a more advanced reasoning mechanism. we should have some kind of plausible reasoning and some kind of approximative reasoning, because if we don't want to represent anything by a model that could be represented, we want only to concentrate, to focus on something that is really adequate and dependable. And for this reason we need maybe specific reasoning techniques we can develop as a foundation of modeling. Oh my goodness, this looks like a very large program. Maybe we can use it also for programming. I claim yes. Currently we are using models for programming, but we can use modeling to program, modeling as programming, or models as a program. So it means in this case we have something like a ladder of development. Currently we are here. We use it for inspiration and blueprints. The next phase is already available. Look for the showcases, ASM, program generation, the compiler approach, or LaTeX. Models are used to program, or modeling is used to program. The next would be modeling can be considered as programming, or we use models as a program. Of course, this is a development and a program for the next maybe 20-30 years in order to achieve it. Finally, from ASM approaches to a general model science is maybe a very nice path for research, and for this reason we are calling also for some kind of collaboration. We look for a general foundation of modeling. We have to use some kind of stereotyping based on the aspects. We have to have reasoning schemata. We have a number of concept proofs that this is working. If you want to read more, please use my YouTube channel or Academia Edu or something like that from the ResearchGate, at least for the papers I have been publishing. Okay, fine, thank you. You see a lot of models we are using in sciences, partially also in computer science, and I hope you will agree with me that models are the most essential part in our culture.